Our agenda makes a lot of sense today. It is structured very consistently. Now that we've had an exposure to greatness of remote sensing data, we'll have a series of presentations telling us what this data is used for. I invite Sergey Potapov, representing NITP, who will tell us about spatial data in 4.0 industry. A small intro. We've learned about how much remote sensing data we have at our disposal and how small a percentage is being utilized to address specific tasks. So Sergey is actually a guy who knows how to process big chunks of data. Following such greats as Roscosmos, Maxar, CIIS is pretty challenging. But we, as a Russian company that operates closely with all our wonderful software developers as Rakus, Panorama, try to tell you what we do, what we are accomplishing as part of 4.0 revolution. Let me go back a little. The name of the conference used to be From Imagery to Map, if you remember. But then the name has changed at about the time when the 4.0 point revolution kicked in. And it makes a lot of sense, because previously we used film-based satellites. Aerial photography was done by specialized equipment carrying heavy weight payload. We had no drones, no laser scanners. The entire setup was pretty straightforward with the limited computing power. We had a photogrammetric satellite that would drop a capsule with a film. That film has to be developed, and only then we could start processing. A lot of limitations, as you can see. Now, as our colleagues told us, we have a multitude of satellites that acquire data from millions and millions of square kilometers day to day, and that includes satellite, drones, laser-based and other sensors. So, going back to the point, the term Industrial Revolution 4.0 came to being in 2012, and it implies a massive satisfaction of human needs in a variety of fields. The 4.0 revolution is considered to be a challenge that the humankind will have to respond to, and the determining factor is the pace of change, ratio of speed of change to social economic transformation. And we are entering a new temporal era. So what is this era characterized by? First of all, technologies. Technologies that affect us are big data, virtual and enhanced reality, and quantum calculations. These are most relevant technologies in our field of expertise. already told us that Maxar owns more than 100 petabytes of information. So what I would like to tell you is how we handle data and what solutions we bring. Let's talk about the big data requirements. 4.0 industry poses the following requirements. First, it's a global coverage, reliability and relevance, accuracy. Now we're talking about meter and even under 1 meter resolution. Information that is quick to get. Use of various sensors, optical, multispectral, and other sensors that make it possible to receive special data with different parameters. And also, it should be affordable, because basically the data is very relevant and it must be cheap to use, so that not only rich companies but also regular people could use those in their lives. So I'm coming back to solutions that we devised as a result of long-term cooperation with Rakurs. Also, I will make some suggestions to create digital reality and address challenges that Russian society is facing. Digital Earth project is a new concept of Russian remote sensing. Valery Zaichka has already told us about constellation development. Another implication is the development of the ground infrastructure. We'll have a presentation on that later. And creation of seamless coverage of the territory of Russia with satellite imagery. That includes not only reference coverage, but also dynamic one, change detection, and doing other tasks. And creating products and services based on remote sensing data is another criticality. The Digital Earth is part of the Digital Economy program. Its core activities are regulatory framework, human resources, development of competences, information infrastructure, information security. Actually, the latter relates directly to our activities. Next, we have development of networks to satisfy countries' needs in data transmission. Development of Russian reception centers to provide consistently reliable services. It allows to export services of data storage and processing. I would like to point out another important system, effective system of storage and provision of special data to citizens. At one of the Rakurs conferences in Israel, I think, we told you about a project of streaming processing of data received from Russian constellation. Processing of big data using photo mode conveyor with a number of interactive workstations allows generating orthophoto plans, mosaics over millions of square kilometers. Viktor Nikolaevich said that we ran experiments 5 years ago. I think today we would have obtained much better results. But back in the day we wanted to run a few tests to drill some things, and we got 3 million square kilometers of high-resolution mosaic. I'm sure that now the results would have been much better. The technology has been advanced ever since. We can create and update geomosaics, global coverage. In industrial scale, we can create relevant information, which is what Maxar, Roscosmos and the others told us. Global Earth coverage is the must, and it needs to be updated on a regular basis. As for the basic coverage of Russia, it should be used as the common reference system upon which all other data should be integrated. It is essential that all data is intertwined and uses single foundation, where we can integrate interferometric data, data from other sources. Then we will receive an understandable system where we can find our way around. It all starts with the foundation, with the basis. So it's critical that we create such high-resolution coverages. And another important point, another essential task in handling raster data is data organization. When we talk about huge flows of data, one can get drowned in them.
And if we organize the data in a more understandable and easy access way so that people could work with that, not only on super powerful computers, but on iWatch and any other smart gadgets that would allow us to work with raster information, would be great. If we go back into history, we could say that earlier, before that, all rasters information systems like orthophotos were quite difficult to work with because computers were unpowerful and they were quite heavy. Orthophotos and raster information could be used only in a limited way. All the rest was quite vectorized and was easy to manage. And now raster information and orthophotos and all sorts of products developed on their basis are entering the further to the fore, and customers are asking for it because now we have solutions in place which allow us to use raster data for any gadgets and get same results which are used in the vector data. An important solution that we have developed for ourselves to understand how it works, we have organized the data in a tile structure, which allows us to work more actively with the data and use them. In this case, on this slide, you can see the tiling system. In fact, the person always works with the information that he put on the screen instead of, managing huge areas and countries. He uploads the information he needs and then he uses it for his work. That allows them to do it quick and easy. Modern filing systems, unfortunately, we used to have in the past, that's why we developed our own format. were not designed to work with billions of files. That's why their capacity was low. And the product we have developed together with the company Rockers and the PhotoMod will help us solve this. That's why we are actively using it now, which allows us to increase considerably not only competitiveness but also increase, wait a second, sorry, but increase the demand for our data. Jointly with the leading Russian companies, we offer integrated solutions on the use of data both in raster and vectorized in 2D and 3D environments. That would be the Rockers solution, the leader on the aerospace data processing, including UAS data processing. It includes also the Panorama products, the leader in the work with vectorized data, as well as the organization of the collective access to them. These are new types of both global data developed by our company and the formats of visualization. Here, I'd like to tell you what we have to offer. Technologies of building geomosaics based on Earth remote sensing, acquired both from Russian and international satellite constellations. The technologies of building multi-layer raster coverage, having different spatial resolutions coordinated with each other. These are tiling visualization of global data and other solutions that would provide both state, corporate, and private individuals with a high-quality Earth remote sensing data for all sorts of tasks and functions. We can go through this. It includes both cadastre and infrastructure development, planning and development of regions, forest monitoring, agricultural monitoring, land use monitoring, flood management, and emergency management, and many other things. On the slides 6 and 7, you can see some of the fragments of dense 3D model, surface model, and then you can see some of the fragments of a localized 3D rendering of model. Whenever needed, and I mentioned it, that one can build for localized regions of specific region structurized models. And the digital economy program as the technology for the comfortable living environment is also an important task that we have to go about. The territorial management task includes coordination of integrated enhancement of natural potential, efficient use of labor resources, development of social infrastructure, reproduction and conservation of environments, creation of a single transport network, and other processes of socio-economic development of a region. One of the central problems of the territorial management is the creation and ensuring comfortable environment for living of people, and these models will invariably contribute to making such decisions. You have 3 minutes. Okay, I'm coming to an end. Which need to be created under the digital economy program of Russia and will contribute to a comfortable living environment, people with optimized costs. And as a result, we have developed the requirements for organization of geospatial data created under Digital Earth program. Here you can see some of those requirements. Accuracy, they're totally in line with the global data requirements. And on the slide, you can see the modeling for comfortable and safe living. And now I'd like to make a conclusion that the global nature of geoinformation, its big size and gradual introduction of new technologies create new application systems. Russian companies have created an integrated solution on how to use new types of geospatial data that will ensure a new level of application of this data in the decision-making process at all management levels. And the result of this work already exists, which is actively mainstreamed in the lives of Russian citizens and allows us to successfully resolve many problems. And in conclusion, I'd like to say once again that we are prepared to jointly with different companies that I went through to offer you both ready-to-use solutions to work with big data, and also, upon the request from the customer, develop some customized solutions depending on the software and hardware that they use. Such solutions do exist in Russia, and they're actively and successfully used, and they will be further developed in the interest of solving problems of both digital economy and digital Earth programs. Thank you for very daunting work, that presentation that you had. Questions? In your processing chain, which is applied at the moment, when from the acquisition to upload to the portal, what is the time? Good question. An important thing here, it's done quite quickly. We need to acquire and systemize, because first we need, for the conveyors, for instance, we need data to have characteristics of the cloudiness. For that we have used automation and manually. The most time is taken for collection and analysis. After the data are collected, you can do it in one time. But can you give me the exact minutes, hours? How long does it take from acquisition to the uploading to the portal? For instance, for Canopus, wait a second. I should say that we don't work with Canopus so far. We're just starting to test it, or Canopus, because we need a high accuracy information. Because, okay, for resource P then, okay, resource P, if the end product can be generated if, what do you mean, orthophotos or mosaic? What will be the end result for you? Tiles on the portal, from the acquisition time until the tiles on the portal. Simple question, I think. Well, I can tell you that our portal is closed down. But still, you can give me the time, no? 1 week. A week? Well, it depends on the volume. You can do it theoretically within a day. Okay, no more questions. There are more organizational, logistical problems there. Okay, I understand. Thank you, Sergey, for your presentation. You mentioned the accuracy of geo coverages, 3.5 meters. I saw it on the slide. We talked to our foreign partners, companies Airbus and Digital Globe, whether they can do products for large areas for millions of kilometers with such an accuracy. And unfortunately, with, say, accuracy better than 5 meters, and our colleagues said that we cannot do global coverage with such an accuracy. We cannot guarantee it. We're talking about reference coverage for the whole territory of Russia, 17 million square kilometers. Can your technologies ensure 5-meter accuracy for the whole area from Baltic Sea to Kamchatka? Yes, they can. Okay. I rest my case. In some things, we're ahead of everyone. Yet another question?
Spectral images you are using, and what is the greatest spatial resolution you achieve, and what about the world coverage? For example, Southeast Asia is covered by Russian hyperspectral satellite images, and with which satellites and which sensors? Thanks.
Thank you for your question. Unfortunately, we are the department which is not doing hyperspectral. It is our research center on Earth methodology which would be in a better place to answer this question. So I'm at a loss here. I'm not competent enough to answer you these questions. Maybe you should address your question to Valery Zaichko. It is within his competence. And the very last question then, I just wanted to ask you about the data format that you have developed together with Photomod. Can you tell us more about what kind of archiving you use vis-a-vis Letov and CW, for instance? Our format is called BIP format. the contraction is about the same as other formats, but it is embedded into the Photomod software with Panorama and all other software suites which are used in Russia. And we try to make sure that we offer these formats to all developers, and they're prepared to use it. Most importantly, they use it in Photomod and Panorama, and they cover 90% of the territory of Russia. Thank you.